So thanks very much for joining us this morning or this afternoon, wherever you are. My name is Don Bowman. I'm going to talk a little bit about what I've been doing the last sort of year or so and some of the surprises that I've had that relate to cloud computing and specifically security. So my background, I've been around for a while. I'm not even as young as that picture makes me look. But most of my history has been around embedded software, internet, and cloud. And I'm currently I'm building my next company, which is really around advanced cloud security becoming a native feature of the cloud, but also improving efficiency of the users. And that's something, as I've been doing that, I've been learning a lot of the sort of dirty secrets and surprises, and I thought I would share that with you today. In the past, I was the CTO of Sandvine, and most of my background was telecom as a consequence. So, first thing is, you have to ask yourself, why am I switching to cloud? Now, this isn't really applicable to people that are quote unquote born in the cloud. A company that starts today, typically nearly all of their compute needs are handled by Amazon, Google, Azure, and then a set of SaaS providers, Salesforce, Dropbox, and so on. But for the vast majority of companies, cloud is something that you switch to rather than you just start with. And there's two primary drivers. There's two primary reasons that you're looking at, making a change to your infrastructure. The first is called efficiency. So these organizations, what they're saying is there's a cost savings that's inherent in shared infrastructure. There'll be less money spent on air conditioning and batteries and servers, and I won't have to worry about capacity planning. And overall, that makes my business more efficient. I want to do the same thing, but for less money. And the second driver is agility. So these organizations say, there's something I've always wanted to do, but I've really been held back by my infrastructure, my firewall, my server, et cetera. And I want to do something different. And if you sort of cross-join those two drivers in organizations, ones that are nearly entirely driven by agility, they're looking to disrupt something. They want to do something new, something that their competitors aren't able to do very quickly. If you look at ones that are entirely driven by efficiency, really what they want to do is they want to be safe. They want to say, I just want to do the same thing more cheaply. I don't really want a lot of risk. Companies that are trying to do both at the same time, it's a very aggressive strategy. So, you don't see that too often, but those that do, they really make big changes. And the interesting thing here is, you got to get your reason right for the organization. So individuals in the organization may have a different reason than the overall organization, but the efficiency ones, they use a strategy called lift and shift. And really, they're not looking to change the architecture. Same number of virtual machines as they had physical machines, et cetera. They might do what's called cap and grow, where they just start putting extra capacity into the cloud and leave the rest at home, or they might move one function at a time. But the agility-driven organizations, they really set out to say, we're going to reinvent something. We're going to rethink or redo. In my opinion, the efficiency-driven organizations, they're missing something here because, the pundits say that the cloud is maybe about 17% cheaper. The cloud's not cheap. So you're reducing some CapEx and OpEx on your site, but you're shifting that money somewhere else. But the agility-driven ones, it's unbounded how much better you can make your organization. And that's the part that I would be looking at. So what is cloud? So cloud means something different to everybody you talk to. To some people, cloud is just the internet that they use. So they think of Google and Facebook as the cloud. The most common definition that you hear in traditional organizations is relating to virtualization on site. They talk about vSphere. Sometimes they talk about managed cloud, and they say, well, I used to have 100 servers. I sold all of those to IBM, and they manage it back to me. It's managed cloud. That's not really what I'm talking about today. In my opinion, although those might meet some of the definitions of cloud, they're not really that interesting. Really, what we're talking about today is the middle part of the spectrum, which is virtual private cloud. So in virtual private cloud, you go and you get a set of virtual machines from an infrastructure provider, from Amazon, from GCP, et cetera, and then you manage them in some way with some orchestration on top of it. The next stage in that evolution is called just flat out public cloud, where everything you do is public IP, it's out there on the internet, and it participates. And then you start to really get the economies of scale when you start to understand cloud native. So cloud native is very different. In the left side of the spectrum, you're taking a traditional IT infrastructure and you're just making it run somewhere else. But when you start to get to cloud native, you're changing your architecture. You start talking about microservices. You start talking about things that are horizontally scaling themselves automatically in and out as demand comes and goes. You start talking about resiliency strategies where the system is self-healing and it tries to sort of figure out if it's working correctly all the way through rather than traditional alarm management. And the far end of the spectrum is this concept that you might be hearing about called serverless. And despite its sort of catchy name, it's really not serverless. It's just somebody else's servers. But in serverless, what you deploy, you really have no idea where it is. You deploy a container, and once in a while, it gets started on some infrastructure. So today, we're really talking about the middle quadrant of this, from virtual private cloud to cloud native. And the other thing that you hear about in cloud is there's a lot of different something as a service. There's far too many to keep track of. The main ones that people want to think about are infrastructure as a service. So here you're getting basically virtual machines. Somebody else has the storage, the compute, et cetera, and they're willing to lease that to you. The next one is what we call platform as a service. So think about a database. In a traditional sense, a database was software you ran on a server that you ran, and then you backed it up and so on. But somebody's willing to lease you databases as a service, and they'll take care of all the backup and sizing for you. And you're just going to get a database for your application to talk to. And then on top of that, there's a whole set of things that are SaaS, so Dropbox, Office 365, G Suite. There's a lot of different things here, but really what we're talking about is the state of mind. Once you get into a cloud state of mind, you're talking about hay versus house plants. One is just a big field of things you harvest. The other is a single thing that you water and pet and care and have a name for. Cloud is really elastic, on demand, repeatable. It's very buzzword heavy. So the cloud revolution, it really changes your life. So it really changes your life. There's a whole set of things that are kind of interacting with each other that are driving how industry is built today. The first that you might hear about is something called continuous integration and continuous deployment. In continuous integration, software developers are writing software that is being constantly tested. So every time they do a commit, it runs through a test cycle automatically. In continuous deployment, you do your commit. If it passes the test, it goes live immediately. And that's breaking down this barrier of traditional IT applications used to be updated maybe once a year. And now you've got companies that are doing multiple updates per week, and they're getting really good at that. And that concept of continuous means they're delivering value more quickly, more linearly to their customers, which is letting them compete faster. The second thing that's driving that is called agile. Agile is a development methodology, and it's in turn driving things you might have heard of DevOps, which is blurring the line between development and operations. Cloud native orchestration, these are also making things go faster. That's what this is all about. It's shorter cycle time. It's quicker from idea to delivery. Infrastructure as code means that somebody writes a config file and suddenly they've got infrastructure that matches that every single time, which allows you to say, hey, I'm going to launch in a new geography and not worry about it. And one of the other things that's driving that is the source control system. So Git, back in the day, open source was something that, you downloaded a tar file and you installed once in a while. Today, everybody just assumes that something's on GitHub and they can submit a pull request and they can make a change to it on the fly. But also people are deploying stuff live from Git. You're seeing open source software that is being used as part of a commercial offering that is upgrading on the fly. So now you've got a security impact of that supply chain risks. In your organization, if you're hearing any of these words, then you've got cloud. It's all about faster cycle time. And that in turn affects security, which is what we're talking about today. So cloud changes the security world in a big way. And, this presentation, I'm going to highlight a bunch of surprises for me, and they sound a little bit scary, but by no means am I suggesting that you shouldn't continue shifting to cloud. It is absolutely more secure when you're done. I'm much more likely to trust the security of my login to my G Suite than I am to my bank. My G Suite is two-factor authentication, et cetera. The bank is not. So one of the things that's really people struggle with is every single best practice for security is totally upended in cloud. Physical security is something that a lot of people started out with. They said, I have a data center. The data center has a lock on the door, only these 4 people are allowed to walk into the data center. There's none of that concept here. And that just flows all the way through the system. So there's no concept of VLANs in the cloud. So you may have a model today where you say, my production databases and my HR system and my payroll are on different VLANs. You don't have those in the cloud. There's no subnets. So the consequence of that is no penetration testing. You can't get a pen test tool and tell it to go scan a subnet. No physical access control. Patch management. Patch management is a huge field worry time sink for a lot of companies. In the cloud, when you're truly cloud native, you just delete the old container and a new one starts and boom, it's up to date. There's no concept of running apt-get update or Windows update in the cloud. There's no antivirus as a consequence of that. You're not talking about desktop products here, you're talking about servers. And a lot of people can't get their head around why should I have an antivirus in there? But one of the big changes is, you used to have something that sat in a data center and you had 15 different pieces of software that talk to each other, completely walled off from the world. Suddenly that interior, which is called the east-west communication, becomes public. Suddenly you've got these things are talking to each other, and that communication is something that other things can get to, other things in the cloud. So suddenly you need to start thinking about east-west firewalls and how to control that and so on. Outbound internet access, that's another thing. Traditional applications, you would usually not allow them to get out to the public internet. You would say, well, my payroll system, why would I want it talking to the public internet? But now in the cloud, you may be using third-party APIs, payment processing or audit or something like that. And that, as a consequence, it has to have outbound internet access, and that can be very difficult to police and control. And the whole system is inherently shared multi-tenant. But cloud can be, and it is, a lot more secure. A traditional data center design, it's quite complicated for most companies to have multi-geography disaster recovery. You might think you're doing well by just having backups, but the reality is in cloud, you could have data centers in multiple cities in case there's something happens. The cloud has a really great story for what's called identity management. Integrated IAM is sometimes called. And this can allow you to have role-based access control per service. So each of your services, you can control who in your organization can do what with them, which is quite hard to do otherwise. And it has a really great audit. So you'll be able to see who logged into that system, what did they do. There's a lot of features in here, PKI, Vault, simplified encryption. There's a lot of tooling. But a lot of people then say, oh my God, my whole legacy application stack, it doesn't use that. What am I going to do? The lift and shift people say, well, just ignore it, continue as is. The agility folks say, great, I got a bunch of new tools. Let me just start rewriting. You got to watch out for a couple things. Cloud can be difficult. The concept of cloud lock-in is something I think people need to watch out for, where there's a lot of great tools. And if you lock yourself into Amazon, you can end up with an issue with data sovereignty because there's some jurisdiction you need to work in that they're not in or something like that, or it gives you a pricing issue. But there's a lot of new ways to think. So really, you can't make cloud work like your data center. So there's a lot of people that I've talked to that have tried to do this. They've said, well, the one problem that I have with Azure is that it works the way it does. I want it to be walled off and have a firewall at the edge and control that. You're losing the cloud native benefits. You may as well not. You may as well be staying in your private data center. And cloud's going to affect how you work. You're going to switch from having upgrade cycles that are planned yearly to having continuous deployment that's working, a couple times a week. It's going to change how you work. It's going to change your process, and you have to kind of get over that. The first big one here is thinking about your update methodology. So you're going to switch from patching and updating images to rebuild and redeploy because it's safer, and you're good at it because you're upgrading multiple times a week. It's something a lot of people struggle with. They're like, there's no way people are making production changes that often. Yes, there are organizations that have multiple updates per day to things that are in production. And the other thing is, there's a huge change here. Traditional network management systems, so SNMP traps and alarm management and so on, becomes much more self-healing in a cloud environment. There's no more concept of the physical failures like a fan failure and power supply and so on. But also, if an application crashes, cloud is more around self-healing than it is around trying to make each thing infinitely reliable. As a consequence, you spend more time looking in logs than you do looking at alarms. The things that really bothered me, though, the things that it took me a little bit of time to figure out, what I call the head scratchers. And I put a compass here because I think of these things in terms of compass points. You've got something that's coming from north to south, so it's coming from the internet to you. You think of things as going south-north as things from me out to the internet. We think of things in east-west terms, which are my own services talking to each other. So a lot of people are going from a single monolith. They think, okay, I've got one app, it runs on one server, I've got one port open on the firewall, it's in my data center, and as a consequence, all it has is north-south public traffic. It doesn't have any east-west concerns because it's all a big monolith, and it doesn't allow outbound. That's very traditional, your enterprise wiki or something like that. And all of a sudden, they're being asked to move into this new world in which each of the different pieces of that one app are split apart from each other and run on a separate server, which is microservice architecture. And they're making it cloud native, which means they're dynamically scaling in and out, which means they're getting new IP addresses all the time. And then they're moving it into a public IP space in cloud. So now they've got to think about east-west, north-south, and south-north all at the same time. But the big tool that they always used was VLANs and subnetting and firewalls to do this. And as a consequence, they're like, well, I don't know what to do. My process guide doesn't say what I can do here. And then suddenly their team says, okay, and by the way, I'm going to be rebuilding the app, once or more per week and deploying it, which means you can't have a long review cycle. And building that app weekly, it's going to pull in upstream changes back to that Git thing. Every time I rebuild, it gets new software, which is sort of good because I was going to do patch management, but it's sort of bad because now I'm trusting all those people out there on the public internet. I'm like, who are they? How do they secure their things, etc. And I don't have an antivirus product or endpoint security that would somehow trip to say this is what's happening, something's wrong. So how am I supposed to secure this? What am I supposed to do? Well, at least there's a cloud firewall, right? It's included for free in Azure. But then you realize it's nearly useless. It's a one-tuple firewall. It's a very small number of rules. How do you configure it for these dynamic IPs? It doesn't really work. But somehow or another, this is progress, and you're happier because, hey, your business is moving faster, and there's a lot of other things that got better, like disaster recovery. So it is progress. These are the big security head scratches that a lot of people are like, the world is changing. What do I do? So what's new to learn? So the agility folks, the people that are driven by my organization wants to do something new and different that it's never been able to do before. They have a whole new suite of things they're going to need to start to learn. The first one is a field called static application security testing, or SAST. What this does is it moves a lot of the sort of traditional risk scanning, penetration test, vulnerability assessment, and antivirus. It moves it upstream to your build time. So you build your thing that you're going to deploy, and you scan it statically before it starts running. It's an image. And then you make it read-only, and you sign it, and you deploy that, and it doesn't change after that. So why would you need an antivirus in there? All your risks are kind of more knowable. At that time, you have access to all the package inventory, so it's actually easier to do these checks. The common vulnerability rules and so on, that you know exactly what version it is. The second thing they do is what's called dynamic application security testing. This is another thing. You're moving the endpoint security upstream. You're testing dynamically those applications before you deploy them live, and then you're signing it. Read-only file systems. This is another thing. It's a real mindset shift, but it's a best practice. Make your file system for your application be read-only. Then you can just shoot it in the head to upgrade it because it didn't write anything there. Instead of having to manage a change log of who's logged into the system, on my system in team, and changed what file in /etc or what change in the registry, it didn't do that because it's read-only. And that allows you to do the continuous upgrade and deploy. And that's why you don't need to do patch management. Another big thing to learn for the agility folks, there's a concept called ingress and application routing. So they go from a world where each service has its own IP address. My wiki's got an IP and a DNS name and so on, to this new world where there's what's called an ingress controller, and they can put HTTP routing on it, and they can say, route the wiki to here, and they CRM to there, and that allows them to do something called blue-green testing. What that means is you can deploy 2 copies of the thing at the same time, and select some users to go into the new one, the canary. So sometimes you say, hey, I'm going to use my marketing team as the guinea pig. We're going to deploy a new version of the wiki, and only they go there. And it reduces your risk as a consequence. So that's a whole lot of new things that you really didn't have in the sort of non-cloud world. For the efficiency folks, these folks are driven entirely by money. So if it turns out that they're not cheaper, they're going to be very sad people. But there are things that can make it cheaper for them other than just, hey, I'm sharing the server and the air conditioning. And the first one is there's a tool that they may be using called Terraform. And Terraform is one of the market leaders in this sort of infrastructure as code. You define your infrastructure, your network, your servers, your everything as a single file. And it's in a format called YAML. And then you can deploy it on demand, and you can deploy it in different cloud providers. You know for sure your development, your staging, and your production environments are identical because they all came from the same infrastructure as code. You know that all your sites are using the same version because it's controlled in your revision control, and you've pushed it to those sites. So you know that your east and west cloud locations are identical. You don't have to worry about one of them set up differently than another. They do have some firewalling, but it's very, very simplistic. In this model, one of the things that's a bit of a challenge is they start to have very complex VPNs. You see this a lot in people that are using Azure. They're looking for very complicated IPsec VPNs between bits of their own cloud, and that what they're trying to do is to replace the VLANs and subnets that they're used to. I don't think that's a good idea, but that is something that you see quite frequently here. Another thing that they have to watch out for is there's new costs that you never really thought of. In a private environment, you didn't really worry that you had traffic between your front end and your back end, or your wiki and its database. But in cloud, you actually have costs to get between zones and between regions. So it starts to, you start to have these sort of hidden costs you didn't think about. If you just lift and shift without any thinking, your costs are guaranteed to go up. There's no efficiency there. You have to adopt a little bit of the cloud native tooling, or else you're just wasting your time. The easiest thing for a lot of people to adopt is the platform as a service for some of the layers. So, stop running your own database and just lease it. Gives you higher scalability and less of a need for a DBA, and backup becomes simpler. Maybe reporting some of the analytics in your application. The proxy ingress load balancer, rather than having sort of F5, you move it there. These are the minimum things that you need to look at in order to get some of the efficiency gains out. So I'll talk about some of the individual surprises. So the first one, I call it revenge of the NAT. A lot of people have different opinions on NAT. So some people think that NAT is a type of firewall. Those people are wrong. A lot of people think it's just a necessary evil, and it kind of is. We've run out of IPv4 space, so it is what it is. First surprise that I had when I started deploying applications in the public cloud is there's 3 levels of address translation. So this is actually what happens. Imagine your user somewhere on Earth. They come into the cloud environment and they hit what's called a load balancer. The load balancer does a NAT, network address translation, and forwards the flow on to an ingress. So now the ingress gets a flow that the source IP is the load balancer and the destination IP is itself. And then the ingress is a type of proxy server. Typically you'll hear people talking about Nginx as one of these ones. It then in turn does some rule logic and says, this is this service based on its HTTP name, and it forwards it to what's called a sidecar. And the sidecar, it's another type of proxy server that's actually inside your service. And then it in turn forwards it onto your service. Now the service receives the flow, but now it starts from its own IP address. So what does this do? Well, there's a lot of people that have like analytics and logging. They may have business rules around geo-IP restrictions. There's nobody from China allowed to log into my infrastructure. And how do they do that? They get the IP of themselves. Maybe at the end of the year, their auditor comes in and they'd have no results for them. Or maybe there's some data theft and the police are there and they want to know where it went. And you're like, I don't know, it came from myself. This was a really big surprise for me, and it's a challenging problem. Surprise 2, east-west firewalls are very hard in the cloud. So, in the traditional data center environment, you had a big fat firewall at the front. You might have had a firewall between your VLANs, but certainly you didn't have one within the VLAN from services to each other. And the problem is in the cloud, they can all talk to each other. In my diagram here, service 1 and service 2 can talk to each other. And you might say, well, why is this a problem? I mean, it's mine. I trust it after all. But the problem is one of the things in your infrastructure is weaker than the others. And if they all trust each other, then you become as weak as the weakest link. And earlier this year, we saw Tesla got hacked in Amazon, and they had people doing Bitcoin mining in the Tesla infrastructure. And that's what happened is they got in through one thing that was weak, and then they went laterally through the system. It's called lateral traversal. And then they started chewing on it. The best solution to this, you can't make everything infinitely strong. The best solution to this is what's called defense in depth. In a defense in depth model, you have multiple layers of defense, and each one tries to do the best it can, but it agrees that it isn't perfect. So you do your best to make sure service 1 is not hackable, and then you do your best to make sure that what service 1 and service 2 talk to each other is the minimum they're allowed. If they're not allowed to talk, then you control it. But when you get into a public cloud, you might have business policies that say things like development and production networks aren't allowed to talk to each other. And surprise, there's no east-west firewall. So how do you do that? Problem number 3, the supply chain risks. So this has come to light recently with the Bloomberg article around Supermicro and Apple and China hacking and so on. But there's another type of supply chain risk that I want to highlight, and this is you are using software which is in turn built upon packages from other vendors or open source, which is in turn built on things from other, and so on upstream. And that is a huge, huge tree. So one example is earlier this summer, one of the most popular sort of web front end frameworks, which is called nodejs. One of the popular packages in it is called ESLint. It's a development tool that you use to check your source code. And the people that wrote that, there was 4 developers, and 3 of them had great best practices, didn't share their passwords across multiple sites, 2-factor authentication. One person, as you might guess, didn't. And they got hacked on a weaker site. They got their password, and then some attacker was able to publish a new version of ESLint into the what's called NPM, the node repository, node package manager. And then every other person in the world with a continuous integration system, they're constantly pulling new versions and integrating it. And boom, that one push to that repo got into a ton of enterprise software very, very quickly. They found it in 15 minutes. 700,000 people had downloaded and installed it in that time. That's just one package. Every time you build your software, something like 80% of it's upstream, and all of their children might have some changes. Sometimes those changes are evil. And that's why we talk about defense in depth. You can't assume that the inside is perfectly trustworthy and just focus on a firewall to keep bad stuff out, good stuff in. You have to assume that sometimes the evil has already started inside. It got there because you deployed it there. You didn't know. Your vendor had a hack, and they only later discover that. Surprise number 4 for me, egress firewalls are hard. In a traditional data center design, this is easy. I got a bunch of servers. They got nowhere they can go except through my firewall at the door, and I don't allow them to get out. Done. But in the cloud, well, you've got to go out because you've got to get to the cloud APIs for the horizontal scaling and the logging and the health checking, and you're using Auth0, and you're using an analytics database, and you're using Google BigQuery, and all those APIs basically are public internet. And you could try to go down the path of putting in layer 3 and layer 4 firewalls, but you rapidly realize you have to allow the entire IP space of Azure, Google, Amazon. And anybody with a credit card can start anything in Amazon. So you're basically allowing anyone in the world to talk to you, and it's the most pointless firewall in history. So earlier, we talked about the supply chain risk. So you should be worried about covert exfiltration, somebody getting data out of your system, or connecting to a botnet, a command and control channel. It's a big problem because we're not really as worried about people stealing our infrastructure, mining a few Bitcoins. That's irritating. But we're worried about our data getting out there. And then maybe we've broken the law. We've broken GDPR or PIPEDA in Canada or something like that. It's privacy information. It's our customers' financial information. We're worried about the data getting out. So what do we do here? I mean, it's a surprise. Egress firewalls are very hard to do. There's no really simple way to allow these things and deny everything else. So what do? Surprise number 5, there's no subnets. You think of all the tools, and it doesn't sound like such a bad thing, but think of all the things that you use the subnet as a proxy for. Use it as a proxy for groups. I've got my front-end web servers and my email servers and my databases, and oh yeah, they're all in different subnets. And that means that I can do asset discovery by just scanning those subnets. It means I can do inventory management, check what version of software is on all of them. It means I can do penetration testing. I can try to figure out, what's where, who's vulnerable. I can map them to domain. I can say, well, this subnet is manufacturing, this is R&D. Once you get into the cloud, the IPs just sort of fall from the sky in a random big pool, and the host names are random as well. So instead of having patterns and it's like database.mydomain.com, you've got db-big hash.something, and it's really hard to deal with. So there's a lot of downstream ramifications to that subnetting change. So my advice, don't panic. It is actually better. So I've highlighted some of the things that surprised me, and one of the things that my company is working on are fixes for those. There are other fixes that are out there for them. Some of the fixes involve changing how you do business. Some involve changing how your technology functions. Some involve using features that are replacements, and some involve work. But the new ways are actually better. They're there for a reason. It isn't just somebody said, hey, let's make things different and difficult for no good reason. I think that the strict lift and shift is a myth. It's a mirage. It seems like a very siren song. Hey, this will be easy. On day one, I'll just move all my physical machines to virtual machines in Amazon and call it a day. I think that's very naive. Something's going to be different. You're going to be hacked by doing that. You'll spend a lot of time doing it. And it'll be complicated. There's more to it. I think you need to embrace defense in depth rather than try to think about a strict firewall model. You'd have to think about each layer has to have some defense from its neighbors. You have to think about the rest of my application is not necessarily trustworthy. The best way to get here is agile, continuous integration and deployment. Just keep doing things in small bites rather than saying we're going to do an upgrade once a year and each upgrade will improve things. Try to do an upgrade once a week, and you're going to get there a lot faster. And then the other thing is you've really got to pick your battles. It's easy to say, well, I need every single one of these risks to be perfectly solved or my business can't move ahead. But the reality is you're going to go into analysis paralysis. You'll get stuck. So the IP transparency that I talked about up front, where you don't get the IP address from the origin, maybe you can just do away with that for a while. The east-west firewall, you really should have one, but maybe if you don't have one for a while, it's okay. The egress firewall. So pick your battles, pick one of these and then fight it. So that's kind of all I had to present. These were my learnings. Like I said, it's a bit of a mindset shift, and you approach cloud as just a set of virtual machines that really are architected the same as physical machines. And then you end up with, okay, well, cloud is all about this concept of cloud native and many small things horizontally scaling, being dynamically orchestrated. And therefore, there's no more upgrades and no more patch management and no more endpoint security. All the time that I spent doing that, I can now spend solving some of the other problems. So that's kind of where I'm at. So I will take any questions if people want to ask them, either in the chat or Lindsay can enable your microphones. You're welcome to tell me I'm wrong. All right, looks like somebody started typing. This is the part that's always awkward when you're running one of these webinars is, why do you not need endpoint protection on cloud servers? So I guess I'll talk about what a cloud server could be and then why you wouldn't need endpoint protection on necessarily all of them. So at one end of the spectrum, the strict lift and shift, you would still probably do it. So if you said I have a physical server running 9 services on it and I just move it to a big virtual machine there, you probably would keep exactly the same software. As you get to be more cloud native, the first thing you do is you split those 9 services up so they run separately. The second thing you do is you then maybe split some of them again. The third thing you do is then you realize cloud native, it's about only one process running per container, and the file systems read only, so there's no way for them to get in there. Any state that it has is stored somewhere else. So it's stored in what's called a persistent volume, which is kind of like a share that you access, or a database. So those things are kind of at the periphery of your cloud, and that's the only spot you can store something. So now you're not as worried about somebody, getting in and changing a file or adding some software. And then the next thing you realize is, well, I'm truly cloud native. I'm rebuilding this thing and redeploying it 5 times a week. Maybe that's good enough. Like, why would I worry about somebody getting a virus in there if it takes them 3 days to do it and I shoot it in the head and deploy a new one every 2 days? Maybe that risk doesn't really bother me that much. So what you see is that the majority of stuff that is cloud native, it doesn't have any sort of endpoint protection other than it might have what's called mutual TLS. So mutual TLS means that it knows who it's talking to and they know who it is. So we talked about some of those APIs, and you say, well, I've got my wiki, and my wiki uses a database. So the connection between the wiki and the database is mutually authenticated and mutually encrypted, and that becomes its endpoint defense. Is you can't connect to it unless you have that authentication key, and then that in turn relates back to the cloud identity provider and IAM, where, okay, so now how does the database prove it is the database? How does the wiki prove it's the database? And then the person that's acting as a principal on behalf of that, how does Don prove that I am Don when I'm talking to it to make some change? And that's kind of what replaces endpoint protection. You really don't see a lot of antivirus or scanners or things of that nature used in cloud. Any other questions? Like I said, it's as a panelist, you don't really know if everybody is just about to drop off, or there's one in the Q&A. Okay. Q&A. Here we are. All right. Regarding the open source supply chain risk, do we have any advice to mitigate this risk? It's very concerning. So, yeah, I think this is a really complicated area. It's very tempting. You've got a set of very highly empowered developers in your company, and they're bringing new applications on that are bringing, big efficiency gains to your company. So think of all the little tools that have been deployed over the last year. I use the wiki as an example a lot, but it could be like a calendar tool or a meeting request tool or something like that. And the open source revolution has made it so that everything is more transparent. So I'm not saying open source is higher risk. I'm just saying it's easier to see. Now your developers are just going to GitHub and they're getting something. And that thing in turn has upstream, and that thing in turn has upstream, and all the way up the chain. How many of you do a really great job of signing your own software? So how many of you have like a GPG key signing thing where the root key is kept in a safe that is held offsite at your lawyer, and you need 2 people present to get that, and et cetera? It's really hard to do that. And some companies are doing a good job there. Like some of the open source things like Debian or Ubuntu, all of their packages are signed, and at least they came from them. But when you start talking about using a package directly from Git or from nodejs or PyPy or one of those things, it imports a lot of stuff, and those things import a lot of stuff. And the update rate, because of the agile and continuous, is so high, you can't really be scanning all of it. Like you couldn't review all the code. So what replaces that is, in turn, it's the number of eyeballs. So open source has sort of traded off long release cycles and review with there's so many eyeballs on it. I gave you that Node.js example. They found that in 15 minutes. And I think if that had been a piece of enterprise software that was released a traditional way, that might have been a lot longer. So I think that's a big trade-off there. And I guess the other thing is you could look at heuristics. You could look at, the behavior of your application. And if it's doing something that's risky, then you could maybe flag it. Lee asks, is the east-west firewall something that you think cloud providers will build into their infrastructure? Yeah, I think so. So from their standpoint, I think they believe it's mission accomplished already. When you start an instance in the cloud, whether it's a virtual machine or a container, their API, their UI, it gives you access to ports. You can say this thing allows port 22 in, or allows ICMP out. Um, and that's a one tuple firewall. So you say, I allow port 22 from anywhere in the world. With some limited scale, you can then put a subnet in or so on. You could say, well, block everything and then allow this source subnet. That sounds pretty strong, but then you realize, going back to the random IP problem, that you can't really configure those things. So I believe that they think it's there. There's a concept in the truly cloud native world called service mesh, which is coming along, which is sort of addressing the east-west firewall a bit. And you see that, for example, the Google Kubernetes engine, you can enable, it's called Istio. You can enable it with one click. With Microsoft Azure, you can enable something called Calico with one click. And those allow you to have some of the features of the east-west firewall. So I think that they will start to do it. But the reality is, from the cloud provider standpoint, application health and application security is absolutely not their problem. They are a platform provider. They will provide you all of the tools. They will provide you some docs that talk about best practices, and they will nod concernedly when you talk about how sad you are that you've gone out of business because you lost everything. But they will absolutely not take ownership of that. They're never going to do that. For that, you'd have to go to a managed SaaS provider, and you have to say, look, I don't know how to do this. I'm just going to go to Salesforce. Cassio asks, any thoughts around PaaS? So things like Heroku. So that's kind of more down the serverless path. You're just controlling the application. So, Google has, the Google App Engine. Heroku is another thing like that. In these models, you build just the application. You don't even package it as a pretend OS like you would in a container world, or a virtual one like you would in an infrastructure or instance model. You just push something there. And I think that in those models, you have to think about, the only hardening I can do is inside my application. So the testing there is, we're going to rely more on the SAST and DAST things. We talked about the static application scanning, the dynamic. So at the time you design your application, you're going to be doing fuzzing, chaos monkey. You're going to try to make it as close to perfect as you can. And you're going to assume that's a very hostile environment that you're in. You're going to have to read up on best practices. Like, you don't open your encryption key and keep it open. You're going to have to look at using a service like Vault, like from HashiCorp, and go and get your SSL root key, open it, use it, close it immediately, and then zero out that memory. You have to assume that's a very, very hostile environment. Antoine asked, do you think that the lifetime for IaaS will be shorter? So there's a two-ended curve here. So in people that have orchestration today, and orchestration means that their software is deployed automatically by other software. So Kubernetes is an example, but Terraform is an example. These things can live as short as half a day. And in some cases, it's very, very short. It's minutes or hours in serverless. So yeah, this lifetime is really short, which is why I'm saying I wouldn't bother with the endpoint protection and the alarm management and the logs, because that machine's going to be gone by the time you get the message. You're still responsible for securing the OS. Yes, when you're deploying an instance, but I think the lifespan of them is very short. Now, I said it's a sort of a two-ended curve. There's a small number of them that live for nearly infinitely long, and there's a large number of them that live for very short. The ones that live very long, yeah, you've got to think of it as a server that you own. Like, if I create a virtual machine and I expect it to be running year after year, I'm going to be doing OS upgrades. I'm going to be worrying about rotating my SSH keys. I'm going to be worried about all of that other stuff. I'm saying in the limit, once you move into cloud, you start to realize what cloud native means. Those become less important to your business. You start to think about those as legacy to be removed, not something to be embraced. We got any other questions there? Okay, well, I guess thanks very much for your time this morning, this afternoon, this evening, depending on where you are. If you have any follow-up questions, you're welcome to reach out to me. My email address is don, at agilicus.com. I think it was linked on the first slide there, or you can join me on LinkedIn. Even if you think that I'm totally wrong and you want to argue it with me, I'm totally willing to hear that. Uh-oh, we lost the ability to go back. There we are. But anyway, otherwise, thanks very much for your time, and see you next time.